Okay, this curve is called a Leminscate. Now, one thing to notice about this is we got r squared. Secondly, in all Leminscates, we're going to have 2 theta there, not anything else. Okay, so here's what that looks like right here. So, it's like infinity, but actually it almost looks like a 2-leafed rose. Where let's see, we went out 1, 2, 2 in both ways. And they both were out on the x-axis. And looks like a figure 8 kind of thing, just something sort of like that, like an infinity on it. So the length is 2, and the alignment was along the x-axis. Well, where do you think we can get to 2 from for the length? So if r squared is 4, what's r? Y along the x-axis? Well, r squared is equal to 4 when the cosine of 2 theta is 1. Because 4 times 1, well, again, same trig abreast, same solving for theta. That trig equation, 2 theta has to be 0. So theta is 0. Yep, it looks just like where the first leaf is. Okay, let's just take a look and see what happens with that. Why it goes that way. Now, I have, just because the way it has to be, I can't put r squared here, I gotta go r, solve for r, so you got the plus or the minus the square root. So notice, as we go through the angles, I'll go all the way back to 0 here, and I'll drag through. So there's your positive and negative r's for those same angles. Boom. Uh-oh. What's happening? Nothing's happening. Exactly. Because, again, between this here, which is about pi over 4 times 2, and this here, is like, back it up a little bit, is like, oh, that's 3 pi over 4-ish times 2. The cosine of the angle of the 2 theta is negative. So the square root of an imaginary number ain't going to be there. So we go around, and next thing you know, ta-da, we're here. Back it up a little bit at pi, and we've completed, and then we do it again, and notice how, if you look closely enough, you could see it duplicating and doubling up to make twice as dark. So that's why sometimes it looks like there's nothing going on, because this here is a negative value, making it an imaginary graph. So when we're looking here, whenever this cosine of 2 theta is negative, it's gone. It disappears because we need r squared has to be positive. That's why we only have the 2 leaves for the Leminscates as opposed to the 4 we would have for the rows. Okay? And let's go to the next one over here. So, Leminscate. Again, how do I know? R squared and 2 theta. Those are your 2 keys. Your length of the leaf, well, again, picture that being 1, so r squared is equal to 9. What's r? Alignment, well, if the leaf is 3 units long, if r is 3, in other words, when is 9, or 3 squared, equal to 9 sine of 2 theta? So when is the sine of 2 theta equal to 1? Sine of what angle is 1? So that means theta is 45. In fact, In Leminscates, that's always going to happen because it's always going to be 2 theta. So, for our graph on the pi over 4, or the 45 in this case, 1, 2, go out 3, 1, 2, 3, 1, 2, 3 here on the opposite, and then you would draw your figure 8, your Leminscate. Leminscates get the figure 8. Okay. So here's your general equation. The length of the leaf is a. Notice it's a squared here and here. Alignment for sine of 2 theta, it aligns along pi over 4 or 45 degrees. For the cosine of the 2 theta, it aligns along the x-axis. In other words, 0, 180. Okay? How about here? Got r squared and 2 theta. I mean, Leminscates, so we're going to have our figure 8. Length. Well, what's the square root of 6? Well, that's going to be somewhere about 2.5-ish, I guess. Close enough for what we need to. And because it's the sine of 2 theta, the alignment is along 45 degrees. So 45 degrees go 1, 2, and some skosh. 1, 2, and a bit. Oops. Put that on to 30 instead. And then the figure 8. That's all there is to it. Right then and there. Boom, done. Okay. That's it for Leminscates. Pretty straightforward because there's not much to do with them because of the r squared and the necessity to have things being positive. Okay, what about these? Look a little different. In fact, a lot different. There's no trig, but there's no r. So this is the case. This is just a line. Now, if you think about it, where is theta 225? Well, right here, and since the equation has no r doesn't matter. Well, those are all your positive r's. What happens if r is negative? Well, it goes in the other direction. So all of these here are going to be lines. They're actually going to be, erase that, through the origin. That's all. Or through the pole. And you just draw it through at that along that angle. So here, where's negative 5 pi over 6? Yeah, I know we're thinking that we're in degrees. That's okay. Remember, every 30 is a pi over 6, so 1, 2, 3, 4, 5 pi over 6. So for the positive r's, the negative r's just go in the opposite direction, and that's it. That's all there is to that. When there's just a theta, it means that's the angle. And that's going to give you the line. That's all there is to those.